Alright, welcome back, ladies and gentlemen. We're looking at section 2.5. We're going to be day 1 of this. We're going to do zeros of polynomial functions, and we're going to find those zeros by hand. Okay, hopefully you identify that as a chiller font. Anyway, we're going to be determining possible rational zeros here, and the question is if the number of the blank of that polynomial below, trinomial technically, was factorable, what are the possible solutions to the equation? Alright, so I'm looking at this guy, and, well, if I'm able to factor this guy, well, maybe that 4 doesn't get broken up into anything and stays as a 4 and a 1. And then that 5, I don't have too many options. Maybe I put a 1 there and a 5 there. Now, granted, this plus sign could be in front of a negative some number. But for now, let's assume it's positive. And basically what that would mean is I'd have a 4x plus 1 or an x minus 5. All right. So given that, my solutions would be x equals negative 1/4 and negative 5. All right. But that's of course not the only possibility. We might be able to take this guy differently, put the 5 there, and then we'll put the 1 here, so that the 4 would hit the 1 and the 5 wouldn't, basically. And then putting in the plus signs there, my solutions now are negative 5/4 and then negative 1. Alright, but of course that 4 doesn't have to stay a 4 if I can factor. Maybe I can break it up into 2x and another 2x. Alright, and then I can have a 1 and a 5. Now here, granted, because there's two 2's, the order here isn't going to matter because each of them is going to hit a 2 when you think about foiling it out. So as I throw my pluses in here, this is basically an exhaustive list of every possible combination, at least of the numbers. We'll deal with the signs again in a second. But basically I have 2 more possible answers, a negative 1/2 and then a negative 5/2. Okay, now what I was saying before is this plus sign was actually a plus in front of some negative number. It would open up the possibility of having 2 negative signs in each of these parentheses, and the result of that would be that we'd have plus or minus each of these numbers as possible cases, because having the minus signs in there would open up the positive version of each of these numbers as a possibility. Okay, now the point I want to make by this is if you look at the numbers we end up with, it's all various combinations of 1s, 4s, and 5s. And notice though that the 1s and the 5s are all numerator numbers, and then the 4 and the 2 all end up being denominators. Okay, so moral of the story is that this number here on the end ends up being the numerator, or at least its factors end up being the numerator, and that number in the front, well, that's where the denominator, if there is one, comes from. Although again, technically, of course, they all have denominators of 1 if there's not another denominator there, but let's not pick too many things apart right now. Alright, so that big spiel, hopefully it made a little bit of sense, but basically what that leads us to is a basic theorem here, and it's for any polynomial function, f of x equals, okay, now what we have is p being the lead coefficient, and then x to the n is just basically whatever power of n you have as your highest power term. And then we're going through however many terms you have, and then down to q, our constant term. Alright, the possible rational zeros for that guy, that polynomial function, and again, keep in mind that rational just means we're talking about nice fractions. So we're talking about 2/3, we're talking about 17/58, you know, and what I mean by that is being nice is it's not an irrational number. Irrationals, of course, are things like square root of 2, pi, any sort of thing where you don't have a terminating or repeating decimal if you think of the decimal form of it. Alright, but anyway, the possible rational zeros are all made up of the plus or minus versions of the factors of q, which is the constant term here, all over the factors of p, which is the lead coefficient, and the stuff in the middle really doesn't matter. So basically when we're talking about the possible rational zeros here, all I'm looking at, even though this is a huge long polynomial, I'm just looking at that 5 and that 10. And then again, basically what I need to ask myself based on this theorem that's up here is what are the factors of kind of my q, which in this case is 10. Alright, well of course factors of 10 are 1, 2, 5, and 10. And then likewise I need to know the factors of my lead coefficient, my p if you will, and in this case it's a 5. And 5 is a very nice prime number, so all we have is a 1 and 5 to work with. Okay, so at that point, my possible rational zeros, brace yourself. Okay, so here's basically what I like to do. I like to take my various numerator possibilities, alright, and then I basically take them over the first denominator, and then I take them over the second denominator, and then I take them over the third denominator, etc. And basically I rule out repeats as I go through it. And so plus or minus 1 is my first one, then I've got plus or minus 2, because I'm putting these all over denominator 1, there's no denominator to worry about, and plus or minus 10. Okay, so now I've used them all with a 1. Now I'm going to use them all with a 5. Alright, so I've got now plus or minus 1/5 as a possibility, and I've got plus or minus 2/5 as another possibility, or technically I guess a pair of possibilities. Okay, and then I've got 5 over 5. Well, that'd be 1, and I've already got that, so I don't need to worry about it again. And then I've got plus or minus 10/5. Well, that would reduce to 2, and I've already got that, so I don't need to worry about that either. So I'm going to kind of morph that comma into part of my box here. So there's a complete list of all the possible rational zeros of that polynomial. And we're going to use that list later, but for now we're just getting the list together. Alright, now another thing that we're going to need to do before going to the bulk of the work that's going to be finding the zeros of these things is determining the number of possible positive and negative real zeros that there are. Okay, important distinction here is what we just did is talk about the rationals. So we looked about the nice fractional ones. Now here we're looking at reals, and so if we're looking at reals, all that means is we've got no I involved. Alright, so the other test had nothing to do with whether or not square root of 3 was a good answer. Here we are worried about whether or not square root of 3 is an answer. So it is important to realize that they don't exactly test for the same kind of thing. Okay, but here it is. And some guy, Descartes, came up with this. So it's called Descartes' rule of signs, if you want to get picky about it, but here we go. Alright, the way we do this is the number of sign changes in f of x is the possible number of positive real zeros, or the number reduced by a multiple of 2. And we'll make a little more sense of this hopefully in a second. And then the number of sign changes in f of negative x is the possible number of negative real zeros, or again that number reduced by some multiple of 2. Alright, now that sounds probably like crazy, so let's put it in action and see if we can make some sense of it. Alright, so anyway, in terms of sign changes, now I'm starting out positive here. So basically there I'm starting positive, and as I continue along this guy I'm still positive on this next term, and then when I hit this term notice I've changed to negative, so now there's one sign change. Okay, now I'm on negative mode. So as I continue through the polynomial I hit a negative again, so it's not another change because I'm still negative, but now I hit my constant term, I'm positive, so that makes my second sign change, and then basically I'm at the end. So basically in terms of the number of possible positive real zeros, so possible positive real zeros, okay, and this guy could either have 2, or again I could reduce by a multiple of 2, or he just might have 0. Alright, so there's 2 possibilities for that. So either he's got a couple or he's got none, and that's all I know right now. Alright, so if I take a look at negative x now to do the second half of this test, good old Descartes. Okay, so now I'm plugging in negative x. Okay, so as I do this without doing too much, okay, anytime I have a positive power, an even power, I'm going to end up with basically what I started with, because an even number of negatives will cancel each other out. But anytime I have an odd power, I'm basically going to have kind of an extra negative, so it's going to change the sign of the term. Alright, hopefully that made sense. And so basically as I plug in f of negative x, or I plug in negative x, I get 5x to the fourth, but now I'll have a negative 7x to the third. I'll maintain the negative 4x squared, but the negative 12x is going to change to be positive, and then there's no letter to plug into for the 9, so of course he's going to stay positive as well. So now the possible negative real zeros this guy has is going to be based on the number of sign changes again. So again I'm starting positive, and now I hit a negative, so there's my first sign change. Okay, I'm still negative here, now I'm positive there, so there's my second sign change, and then this guy lasts until the end. So kind of like with the positives, I might have 2 negative zeros that are real, or I might have none for this guy. Alright, and if you're looking at that going, well, there's 4, well that means it's got to be 2 positives and 2 negatives. Well, don't forget that there might be some complex zeros. So it's possible actually it's 0 and 0, and all 4 of them are complex or imaginary. And so we can't make any sort of assumptions yet. Alright, so now here's our basic method for finding zeros by hand. We're going to determine the possible rational zeros, again just looking at the fractional ones. Then we're going to determine the possible number of positive and negative real zeros, so again not necessarily just rational, we might have some of the icky square roots and stuff like that. Then we're going to test possible rational zeros until we find one that works, and we're going to use synthetic division for that. And then we're going to test other possible zeros on the depressed polynomial you'll get from finding that first zero. Alright, in step 3. And then 5, we're going to repeat step 4, keep testing more and more until we get down to a quadratic, because as soon as we get down to an x squared, well, we can either factor it or use a quadratic formula or something like that. And then we can easily repeat number 1 through 4, but then that's a lot of work. So honestly, to me, after you get one and have a different polynomial that you're looking at, it's not worth the effort, although you've been welcome to go through the effort of doing all those steps again, but I'm sure nobody's really going to want to. So anyway, let's stick with that, and here we go. Alright, so looking at our first polynomial, x to the fourth plus 3x to the third minus 11x squared minus 3x plus 10. Okay, now again, the possible rational zeros are factors of the constant term divided by factors of the lead coefficient. Okay, now this case, well, 10 is very nicely factored into 1, 2, 5, and 10, and then now we have a lead coefficient of 1. So really, long story short, possible rational zeros, plus or minus 1 over 1, which I'm not going to bother to write, plus or minus 2 over 1, plus or minus 5 over 1, or plus or minus 10 over 1. Okay, and again, since it's just a 1, there's no other option, so I'm not going to make any sort of fractional versions of any of these things. So there we go. Okay, number of positive real zeros. Okay, going through my original polynomial. Again, I'm starting positive, and I go across here, and I hit a negative sign, so that's my first change. I continue through negative, and I hit a positive right there, so there's my second change, and then to the end. So I've got either 2 or 0. Alright. Then now, looking at f of negative x, well, that's going to be x to the fourth. Again, even, I don't change. Odd, my next term, now he changed to negative x to the third. And now I maintain the negative sign on the 11 with the x squared. And now this next guy changes to a positive 3x, and then we have a positive 10. Okay, so kind of like the beginning example I had here, I'm starting positive, and I hit a negative change here. And still negative, but now I switch to positive, so it's my second, and then I make it to the end of the polynomial, so there's either 2 or 0. Okay, now the reason this is important, because if one of these works out to be 0, let's say, then that means I don't need to try any of the negative or positive, whichever one was 0, as my guesses start. And then, like I said, here's the guesses. Basically, step 3 of my list is we're now going to pick one of these guys and test it out and see if it works. Alright, and really I have 8 choices. Plus or minus 4 different numbers, 8 choices, so basically just pick one and run with it. I like to start with 1s just because 1s are nice small numbers. So I'm going to pick positive 1. Okay, if I pick positive 1, okay, again, technically that's an x minus 1 is a factor, so I'm putting a 1 up in my box. And then I've got 1, 3, negative 11, negative 3, and 10. Alright, so setting up the rest of my synthetic division, drop the 1, get a 1, there's a 4, multiply gives me a 4, gives me a negative 7, negative 7 times 1 is negative 7 again, gives me a negative 10, and looks like I got lucky on my first one and got a 0. Alright, so that 0 I'm happy about because that means I've found myself a factor. And so now I'm looking at, again, now an x to the third, 4x squared, negative 7x minus 10. To me that doesn't look very factorable, so I need to find another one. Okay, and now I found one of my positives, and now what I know is, hey, there's got to be at least 2. Because obviously it's not 0, so I know there's one more positive one out there. Okay, and one thing that you might want to do at this point is start guessing around again. And so one thing you could do is use 1 again, but just for the sake of argument, I'm going to start with 2. I'll just recopy this for notes purposes. Alright, and see if 2 gets us anything here. So I'll drop the 1, 2 times 1 is 2, that gives me pretty clutch to 6, 12, gives me a positive 5, and looks like I got lucky twice in a row because I got a 0 again. Yay! Okay, so now basically right now I found 2 zeros and have run out of space. So we're going to kind of jump to the next slide. Alright, so now just continuing on this problem, I've got the 2 synthetic divisions from above. So basically what that means so far is that I found 2 zeros. I've got x equals 1 and 2. Okay, again, the number up in the box is the actual 0. Okay, and now looking at this 165, again, what that means for us is that basically I'm down to x squared plus 6x plus 5. Okay, and again, I'm imagining that this is equal to 0 because I'm trying to find zeros. Okay, now at this point, either I can use a quadratic formula, or if this guy's factorable, I can just do that. Well, fortunately for us, this guy is factorable, so this breaks into x plus 1, x plus 5 pretty quickly. And then that gives me a negative 1 and negative 5. Okay, now remember our prediction before is to either have 2 or 0 positives and 2 or 0 negatives, and there they all are. So basically now, just to put together a final complete list of zeros, my zeros are negative 1, negative 5, the 1, and the 2 from earlier. Of course, you could use plus or minus 1 if you want to shorten up that writing, but there it is. There's a complete list of zeros for that original polynomial. Alright, let's take a look at another one now. I'm still dealing with something with x to the third, but now I'm dealing with a coefficient. So that's going to make our possible rational zero list a little bit longer. And here it is. Okay, the 15 gives me 1, 3, 5, and 15. But the 2 gives me a 1 and a 2 as my possible denominators, basically. So my possible rational zero, starting out with using the 1 from the 1 and the 2. Alright, I'm going to have 1 plus or minus 1 plus or minus 3, 5, and plus or minus 15, but unfortunately, since I've got another factor available in my lead coefficient, I've got to consider that as a denominator, and so now I've got plus or minus 1 half, plus or minus 3 halves, plus or minus 5 halves, and then lastly plus or minus 15 halves. Alright, so I've got a pretty long list of possibilities there. Okay, now looking at my possible positive reals, okay, again, looking for sign changes. So I start out here at positive, now I'm looking to switch to negative, and it never happens. So basically what that means is there is 0 chance of having a positive real 0. Okay, and the good news for that is now my list here gets cut in half, because as far as plus or minus goes, I know there's no positive reals, and since rationals are reals, basically I can lose the plus half of each of those. So when I'm starting to test, I'm just going to start picking negatives, but let's take a look at this just to get a little more insight. Okay, as I plug in the negative x, I get now a negative 2x to the third. I maintain my positive 13 on the x squared, but now I have a negative 26x. And then again, of course, that last guy can't ever change because he's not attached to an x. And there you go. Okay, so now I'm starting negative, and here's one change as I hit a positive. Here's a second change as I go back negative, and then a third change as I get positive again. So I've either got 3 or 1 negative real zeros, which is kind of nice, although again I've got 0 there. So as far as my choices, like I said before, I'm only going to pick negatives here. And just to get started, I'm going to pick a negative 1 because again I like 1s, they're easy to work with. I got my 2, my 13, my 26, and my 15, and I'll start my synthetic division and see where we go. So I drop my 2, I get a negative 2, 11, gives me a negative 11, and in a very, very nice way, I get a 15, negative 15, which puts me to 0, and again, I'm just ecstatic over that. Alright, so now that's what I'm looking at, and the good news here is that now I'm down to a quadratic already. So I've got a 2x squared plus 11x plus 15 equals 0. And for space concerns, I'm going to go on to the next. Alright, so just picking up where we left off, I'm at a 2x squared plus 11x plus 15 equals 0. And again, okay, you can either hit that thing with the quadratic formula if you don't think it's factorable, but this one is. Okay, again, if you're a borrow and paybacker, go ahead and do that. I'm not, so I won't. Alright, so again, I got this, and I just got to play around with the 15 to try to make an 11. Okay, so I go 1 and 15, no, but then I go 3 and 5. Well, to make an 11, if I throw a 3 there, that makes a 6. And the 5 there, well, it makes a 5. And 6 and 5, I'm pretty darn sure makes an 11. So here's my factored form. So I've got my x equals negative 5 halves. Got my negative 3, and then of course, got that negative 1 that I found earlier. Please don't forget to write those guys from the synthetic division as part of your answer. But then there's 3, again, all negative like we kind of predicted, and again 3 of them because I started out with an x to the third. So there's all my zeros for this guy. Alright, let's take a look at one more. This guy is a little bit nastier because he's an x to the fifth, although he is nice and he doesn't have a lead coefficient, at least for our possible rational zeros here. So let's get into this here. Okay, now 12 does have a lot of factors on its own, but again, no lead coefficient means I don't have to worry about fractions here. So I've got my plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12 is my possibilities for rational zeros. OMG. Alright, now my number of possible positive reals, again I'm looking for sign changes. Starting at positive, hitting my negative gives me my first change. Going through here is it. So I've got one positive real 0. Again, emphasis on real. Alright, now my negative x going in gives me a negative x to the fifth, plus 2x to the fourth. Now a positive on the x to the third. Okay, still a negative on the 2x squared, a positive on the 6x, and now I'm negative on the 12, or still a negative on the 12. But as far as sign changes now, I start negative and I turn positive, there's a 1. And I come here and I hit a negative there, so there's my second sign change. Back to positive is my third, and then hitting there gives me a fourth sign change. Okay, so as far as possibilities for negatives, I might have 4, or I might have 2, or I might have 0. Okay, so I have a lot of negatives, or at least potentially a lot of negatives, and I have a very thin number of positives. So as I start picking, I'm going to start picking negatives first, just because it seems like I've got a lot more of those. So I'm going to try again my 1s, those sound good. And so I'm going to go with my 1, 2, negative 1, negative 2, negative 6, and negative 12. Alright, put my synthetic division here. We got 1, negative 1, gives me a positive 1 there, gives me a negative 1 there, which gives me a negative 2. Now multiplying gives me a positive 2, gives me a 0 there. Zeros are kind of nice in general. Gives me a negative 6, and now gives me a positive 6, and then that gives me a negative 6. And now unfortunately that wasn't a 0, so I have to try something else with the original. And again, I don't have many positives, so I could try positive 1 here, but just honestly because I know how it's going to play out, I'm going to try negative 2. Alright, now I'm back to the 1, 2, negative 1, etc. Alright, now when I do my synthetic division, and again, just because I know how it's going to play out here, some good things are going to happen in just a second. So I get a negative 2, it's a 0 there. So I get a 0 there, that's a negative 1. And now I get a positive 2, and that's another 0. Kind of odd. 0, I get a negative 6. And then negative 2 times negative 6 gives me the 12, and then there's a 0 there. So yes, I'm just ecstatic again. Alright, and again, for space concerns, let's move on. Alright, now picking up from where we just left off. Looking at this thing and noticing that we've got a whole bunch of zeros in there is actually very convenient for us, because right now I'm looking at something with x to the 4th that normally isn't factorable, but x to the 4th, since I'm missing a couple things, I've got x to the 4th minus x squared minus 6, and setting that thing equal to 0, well, that's something that is there very nicely factorable. I can factor that into x squared and an x squared. Again, if you're a u substituter, of course, you'd say u equals x squared and have a u and a u here. But anyway, okay, I'm going to go with a positive 2 and a negative 3, which will give us what we're looking for there. So now I can break this into x squared plus 2 equals 0, and then x squared minus 3 equals 0. And then hopefully within a couple steps you can get this guy into x equals plus or minus, please don't forget the plus or minus, I root 2. And this guy, again, in a couple quick steps, gets me but x equals plus or minus root 3. Alright, so again, with the plus or minus on each of these guys, there's 2 solutions here, 2 zeros if you will, and there's 2 zeros there, and then again the 0 that we found from the synthetic division gives me a complete list of the 5 that I was looking for, again, because I was dealing with a 5th degree polynomial. So I get the negative 2 from the synthetic division, the plus or minus I root 2 from the left half, I suppose, and then the plus or minus root 3 from the right half. So there is, again, all 5 that I was looking for, and if you do check back that our initial predictions do check out with the number and type of zeros that we did find. Alrighty, so just to break tradition here, instead of a bunch of problems out of the book, I'm just going to give you 6 of the ones like I demonstrated here today. So basically do what I just did as examples, find the rationals, then the real positives and negatives, and then use that to kind of shape your guesses as you use synthetic division and or whatever other things to find the rest of the zeros. There you go. See you guys in class.